Yeah, 9a minus 6b equal to 0, right? So I would take that and say, okay, so a is equal to 3 halves b. That's pretty nice. I'm going to store that away, right? And how about the last two equations? Can I do anything? I can do the same trick there because I've got a d on both ones, right? So if I subtract equation 3 and equation 4, what do I get? Yeah, I say, yeah, minus 9a minus 3c equal to 3 minus 0, which is 3. Right? Now, for this one, I can solve this for c, right? I can divide that by 3, and this gives me, you know, I'll bring the 3c to the other side. It's going to give me c is equal to, what'd you say? Minus 1 minus 3a plus b, I think. But I've decided I'm going to get rid of everything except for b from this equation. So since I can trade my a's for b's, I've got, this is c is minus 1 minus 9 over 2b plus b, right? Minus 9 halves plus 1 is minus 7 halves. So c is equal to minus 1 minus 7 halves b, right? So let me call this one Pac-Man, call this one Ghost. And now what do you do? Right, well, I mean, pick your favorite equation. We can go back up to like equation 2 or, you know, whatever, and figure out what b is. This is equation 2. So from 2, we get 3a, which was what? A is what? A is 3 halves b, right? And then plus 2b. To b or not to b? Oh, I'm sorry, that was horrible. And then c is minus 1 minus 7 halves b. Hooray, we now have one equation, one unknown. We can figure out what b is. So this method I'm showing you is what's called elimination. Right, we have a system of equations. You just try to reduce the number of letters involved until you get to just one letter. You can solve it. And then you back substitute the things you already know, unravel it. Now, this is not the best way to solve this kind of problem. The best way to solve this kind of problem is with something called row reduction, Gaussian elimination, which is something we teach in linear algebra, which you may or may not have seen in high school algebra. Like, did you do matrices with numbers and row reductions in there? No, see, sometimes it gets left out. Used to be standard, but, you know, it's times they are changing. So this is 9 halves minus 7 halves, which is 2 halves, which is, so yeah, this and that just simplified to give me 3b minus 1 equal to 0. Apparently b is equal to 1/3. Once you know that b is 1/3, what's a equal to? Three halves times 1/3, which is 1/2, right? What's c equal to? Something unpleasant. Yeah, minus 1 minus 7/6. Minus 6 minus 7/6. Minus 13/6. If I haven't made a mistake. All right? This is all subject to me not having made an arithmetic mistake. I'm showing you a method. This method definitely works. Whether or not my arithmetic was completely legit here remains to be seen. And then once you know that, we can go back up to equation 4 and easily find out d is the negative sum of the negatives of these guys. You know, it's so d minus 1/3 minus 1/2 plus 13/6. So that's like, you know, minus 5 plus 13 over 6, which is 8 over 6. So 4/3, I think. So it looks like I'm getting f of x equal to 1/2 x cubed plus 1/3 x squared minus 13/6 x plus 4/3. But I would honestly, I would be kind of surprised if, because I've been hurrying a little bit here, I would be not at all surprised if there's like if that's not exactly right, given the number of steps I've made here. But you could try out some things like, what's f of 1 equal to? Does that work? That's a good check. I mean, that's an easy check. Is f of 1 actually 0? Put it all in the sixths. The first two give you 5/6. You have 5 minus 13 plus 8. So I think that one works. That's not terribly surprising because I used that equation to find d. So if that was wrong, that would be bad. What's the derivative? Actually, let me do something a little bit sneaky here. F of x is what? Factor out a sixth. What is it? It's 3x cubed, right? Plus 2x squared minus 13x plus what? Plus 8. So f prime 1/6, we got 9x squared plus 4x minus 13. Huh. Wah, wah, wah. I'm going to try and check my answer right quick, but there's nothing quick about this problem. Can you factor that? I mean, I'm hoping that, well, I mean, we could try it. Anyway, what's f prime of, is f prime of 1 0? F prime of 1 is 0. 9 plus 4 minus 13. 13 minus 13, 0. F prime of 1 is 0. That's a good sign. Is f prime of 2 0? Well, plug in minus 2 rather. Minus 2. 36 minus 8 minus 13. Oh, sadness. 4. I always like mess up the checking. So minus 2 times, it's 4 times 9 is 36. 36 minus 8. Ooh. I am not seeing f prime of minus 2 being 0 here. So I feel like there's a mistake. I'm just checking my work, you know. But this is, right, I mean, whenever you're faced with a problem like this, you just kind of have to like put everything out on the table and do algebra. There is another way to do this. So here's an entirely different strategy for doing this problem, but it involves something we don't know yet. But so you know f prime of x is what? It's some constant. I'll call it lambda. I don't know what that is, but we know that f prime has 2 zeros, right? And we also know that it can't have a third. Why? The reason I know it can't have a third is because this is cubic. Cubic function has at most two turning points. The derivative can only have 2 zeros. And I know that the zeros are at 1 and at minus 2, so it has to look like this, a multiple of that, you know? And then, so this tells you that f prime of x is lambda times x squared plus x minus 2, right? And then here's the thing that we don't know yet. This, if you undo the differentiation, gives you f of x is lambda over 3 x cubed plus lambda over 2 x squared minus 2 lambda x plus some constant which we've called d previously. And then I can use that. I just need to figure out what lambda and d are. So like f of 1 is 0, but it's also lambda over 3 plus lambda over 2 minus 2 lambda plus d. And f of minus 2 is 3. So that's minus 8 lambda over 3 plus 2 lambda plus 4 lambda plus d equal to not 0 but 3, right? Now you have 2 equations and 2 unknowns. That's easier to solve, right? Can we solve it? I mean, subtract the equations, right? Subtract the equations. What do we get? We get 1/3 minus, that's 3/3. That's 3 lambdas from those. This gives me 1/2 minus 2, which is minus 3/2. Oh, there's 6 here, right? Let me just kind of put this all together. This gives me a minus 6, so I get minus 8 lambda plus lambda over 2 equal to minus 3, if I haven't made a stupid mistake again. So these two gives me the 3, because I get 9/3. And then I've got minus 2, minus 2, minus 4 gives me a minus 8. That half goes down. 3 minus 8 is minus 5. Minus 5 plus 1/2 is minus 9/2. Minus 9 lambda over 2 equal to minus 3. So lambda is what? 6 over 9. 2/3. So allegedly, f prime of x is 2/3 x minus 1 times x plus 2. Let's see here. Does any of that match what we had before? I mean, we didn't have so the leading coefficient is like when I put the 2/3 into here, I get a 2/9, right? So f of x is supposedly lambda over 3, which would be 2/9. Where was I? 2/9 plus 1/3 x, 2/9 x cubed. 1/3, sorry, I'm losing track, x squared. Minus what, 2 lambda 2? Minus 4/3 x. And then plus d, what should d be equal to? when we plug in 1, we have to get 0, right? So if I plug in 1, I get 2/9 plus 1/3, which is 5/9, 5/9 minus 8/9, 3/9. So I think I have to subtract 1/3. So if I haven't made a mistake, I think that's the answer, but does that work? Plus 1/3, plus 1/3. Which is, anyway, I'm pretty sure that will have, I think that's, I mean, I don't know. Like I said, there's a mistake in the original algebra. Here's a really different way to think about it. This thing I did right here is called anti-differentiation. That's what we do after the next test. So, but anyway. Oh, I'm sorry. We seem to be way over. You could have stopped me. I'm just trying to help you.